Hi Daniel, this is just a recap video on the things we did yesterday. So we're going to look at the multiplication techniques we talked about, and then we're going to look at what we can do with them, and specifically what happened with 11 times 11. So just a little touch on differentiation. So from just multiplication to differentiation in 5 minutes. So just recapping really. So I know that you go pretty fluent at most of it. So it's just that you can have a double check over what we did and practice it a bit. Okay, so just a reminder, I'll do the 2-digit technique. We're going to do the right hand column, so we're going to do 4 times 1, sorry, 1 times 2 is 2, then the cross, so 8 and 3 is 11, 4 3s are 12, left hand column, 4 3s are 12, which gives us the 13. Okay. So for the 3-digit technique, we're going to do pretty much the same as that, except in the middle we're going to have that Union Jack situation, so it's going to start the same way. 2, cross is going to give us 5, and then Union Jack is going to give us 2 and 3 and 2, which is 7, then the cross again, so that's 7 as well, and then left hand column 3. And for the 4-digit method, it's all of that, except there's also a double cross for the 4th step. So it's like you said in the pattern yesterday, it's going to go 1, 2, 3, 4, 3, 2, 1. So 1, 2, 2 and 1 and 1 is 4. And now it's double cross, so that's the outers, then the inners. So you've got 4, 3, 1, 2, 4, 3, 1, 2, which is 10. 1, 2, 3, 4. Then we got just the reverse of all those things. So 3, 2, 1 is going to be the Union Jack up to here on the left hand side. So 4, 3 and 2, so that's 9, so that's 10 again. Then the cross, 8 and 3 is 11, which is 12, and 4 3 is 12. So we get 13,200,421. So there are techniques. Now, like I said yesterday, we don't really need to remember all those. We can just remember one. Just remember that. If you want, you can use that for everything. If you want to multiply numbers that are 4 digits or fewer, you can use that and it will work anyway. Or if you're just doing 2 digits, you can still use that, 3 digits or fewer. Whatever you happen to be practicing with, you can use whichever one you want to. So in some ways, we don't ever really need to use that again, because it's just part of that one. And then that one is just part of that one, and so on. So it's just about being efficient and choosing the right one for you, depending on whether you're going to find it useful. Just remember the second one with the 3-digit method and just apply it to everything, 3 digits or fewer, or whatever. It's up to you, really. It doesn't matter. The point is that it's there. They're the same thing. One is inside the other, which is inside the other. We then looked at that specific answer to 11 times 11, and we saw that whatever technique we use, we're going to get 1, 2, 1 there. So 1, then the 2, then the 1. And I said that was an important number, underrated number, I suppose, mathematically. And you asked me why, so I explained why, which was that the area of that actually gives a square, multiplying those two numbers together, and the area of that square is obviously going to be 1, 2, 1. Another way of looking at that is splitting up the 11 into 10 and 1. Now here I've actually changed it slightly and done 10 to the power 6, so 1 million. So imagine you had a square where it's 1,000,000 by 1,000,000. This is not to scale, by the way. And you increase it by 1. That's what we're going to get. We're going to get this new larger square on the outside here, where the one in the corner, I can just ignore it really. Just because it's so negligibly small that I'm not going to see, it's not going to make any difference to an area. So the area, the newer area now, will be 1,000,001 times 1,000,001. Right, so instead of calculating that, I'll just add on the new areas. So this area here is just going to be 10 to the power 12, because multiplication is addition, so just add the powers. This area in the rectangle is going to be 10 to the power 6, because it's 10 to the power 6 times by 1. So it's this one. This is just going to be 1, this corner, but 1 compared to all the rest is so small we can pretty much forget about it. So the new area is going to be 10 million. Sorry, a million times a million. So that's a trillion. plus 2 lots of 1 million plus this 1, but like I said, we get to ignore that. So since we started off with that area, the change in the area is just this amount. That's what's changed. This is the new, obviously these rectangles here, this is what the new increase is. Okay, so that's the total area of the whole new thing. But the change, which we actually call dA, which means just a little bit of a change in A, would just be 2 lots of 10 to the power 6. And that's what I said yesterday, that whenever we have a square which increases by 1, or actually increases by any amount, the change per step will be twice the original square's length. So there you go, the original square's length was 10 to the power 6, the change in the area is twice that. So I've thrown some letters in there. Remember yesterday I didn't do any letters, but there's a little introduction to the letters of it, that, you know, A for area, and dA just means a little bit of area. Okay, so that means the change in area in this case. So that was it. One thing I thought about after lesson finished was that, you know, I asked you at the start about the percentage technique, and that you didn't use mine, and that's because what you did was you found 1% and then used that in a variety of different situations, so you didn't have to do the calculation over and over again. And I thought to myself later that what you did there was you normalised it. You found out what the value of 1 was and scaled it up as you needed. And that's quite a mathematical thing to do, isn't it, if you think about it, because I'm always going on about normalisation. This whole picture that I've shown you here with the increase of 1 in the square is a normalised system. In practice, we don't actually increase by 1, we increase by a small amount, but it ends up effectively being 1 because we do a little thing at the end which makes it that way. So I've just skipped all that and just shown you the increase by 1. But I just thought I'd point out that I must have taught you something, because you did something mathematical. Okay, yeah, I look forward to next week, and I'll speak to you then.